In this video, I'm going to show you how to solve a complex exposure settings problem where you might be asked what set of conditions resulted in the highest receptor exposure, or what set of conditions resulted in the lowest set of exposure. Each set of conditions is marked by a letter A through F, and for each set of conditions we have a kVp, an MA, a milliseconds, a grid, and an SID. So my first step will be to calculate the mass for each set of conditions. So for A, we've got 150 milliamps times 500 milliseconds divided by 1,000, resulting in 18.75 mass. In the second condition, we have 200 MA times 300 over 1,000, resulting in 60 mass. In the next set, we have 200 MA times 100 milliseconds over 1,000, resulting in 20 mass. In D, we have 300 milliamps for 150 milliseconds over 1,000, resulting in 45 mass. In E, we have 800 milliamps for 100 milliseconds over 1,000, resulting in 80 mass. And in F, we have 200 milliamps for 300 milliseconds divided by 1,000, which results in 66 mass. Okay, our next step is to scale the masses to find the mass that would result in the same receptor exposure as if it had no grid. So in A, we've got 75 mass with an 8-to-1 grid. To end up with the same receptor exposure with no grid, it would require a lot less mass. As a matter of fact, it's the old mass times the new grid factor over the old grid factor. So we'll take 75 mass. The new grid factor is 1 because it's no grid, and the old grid factor was the grid factor for an 8-to-1 grid, or 4. So in that case, for A, it's saying 18.75 mass with no grid would result in the same receptor exposure as 75 mass with an 8-to-1 grid. We'll do this for the next one, 60 times 1 over 5, because it's a 10-to-1 grid, so that's 12 mass. So 12 mass with no grid would have resulted in the same receptor exposure as 60 mass did with a 10-to-1 grid, which has a grid factor of 5. 20 mass, 1 over 1, because it already is no grid, is 20. 45 mass times 1 over a 16-to-1 grid is a grid factor 6. It's 45 times 1 over 6, so that'll give me 7.5. 45 divided by 6, yeah. All right, 80 mass times 1 over 5, because that 12-to-1 has a grid factor of 5, results in 16 mass. We believe that, 80 divided by 5, good. And 66 mass times 1 over 3, because the 6-to-1 has a grid factor of 3, is, oh, I'm sorry, this should be 200, this is 60 mass, this is 60 mass, that gets me 20 mass. Okay, gotta go slow and catch my math mistakes. All right, that lets us now look at, well, what if they all had the same grid factor? So we've scaled the mass to see what mass with the no grid would result in the same receptor exposure. Now we're going to use the 15% rule to come up with the mass that would result in the same receptor exposure if they all had the same kVp. So most of them have 80s. I'm going to leave 80 alone. So 18.75, 12, 16, and 20 all stay because they're already at 80. So this is saying 20 mass at 92 kVp. Well, that would be the same as 10 it would be the same as, well, if I drop my kVp, that would be the same as 40 mass at 80 kVp. Okay, so I have to multiply my mass by 2 to compensate for the kVp. 20 mass at 92 would do the same receptor exposure as 40 mass at 80. That's a 15% step down in kVp, so I double my mass to maintain the receptor exposure. In D, we had 7.5 mass at 92, which would be the same as 15 mass at 80. Okay, so now we've got 40 mass and 15 mass corresponding to the same at 80 to quantitate the same receptor exposure. So now we have to adjust for distance. So I'm going to say, well, what if they were all at 80? So in the first one, the distance is 80, so I would do 18.75, and it would be 80 over 80 squared, because it was already at 80. It's the distance new over the distance old squared. So that ends up being 18.75. My next one was, well, 12 is my current mass, but that's 12 at an SID of 70. It's going to actually be more mass at a further distance to result in the same receptor exposure. So I'm going to put 80 over 70 squared, which is going to result in 15.67. Here I've got 40 mass, and it was at an SID of 120, so 80 over 120 squared is going to result in 17.78. Here I've got 15 mass, and that was at an SID of 70, so I'll put 80 over 70 quantity squared, so that would result in 19.6. Here I've got 16 mass, and 80 goes up top, and it was at 80 squared, so that's still 16. And here I had 20 mass, that was at 90 inches, so 80 over 90 squared equals 15.8. So that is my, now I can compare these numbers directly, and I can say, well, which one is the highest? Well, the highest is this 19.6. So condition set D is the highest receptor exposure. Which one would be the lowest receptor exposure? Well, that looks like condition B. That would be the lowest. Okay, so we had to scale for, we had to find the mass, we had to scale it as so they all had the same grid, and we chose a no grid situation. So it's really dividing everyone by their grid factor. We had to use the 15% rule to adjust for the different KVPs. And then we had to use the inverse square law to adjust for the different SIDs. If the question was asking which one resulted in the best contrast, you would relax and say, oh, that's great. I'm going to use the highest. Well, it would be a bit of a challenge because the high KVP reduces contrast and the high grid ratio improves it. So I probably wouldn't ask you that because there's too many variables here. All right, so that's how you adjust for grid factors, KVP, and distance. You can do it in any order. And I hope that helps you with these complex exposure problems. XRayBob out.